Okay, so the same thing happened with 10.3 part 1 where the sound didn't work, so I'm going to try to narrate over this as well. So this section is on amortization, and probably the most common application of amortization is with mortgages. And so it's just figuring out how you can pay off principal and balance at the same time, but your payments are always the same amount. So it says a home loan works just like a car loan. It's just generally for a longer period of time and usually a larger amount of money. So in amortizing, some of your payment goes to interest and some goes to principal. And we will construct what's called an amortization schedule in Excel for one of the activities to show how much of each payment goes to paying off interest and how much goes to reducing principal. We'll do a partial amortization schedule in this in these lecture notes as well. So the book gives this formula for finding the payment when you're amortizing a loan. R stands for the regular payment, P stands for the principal or the loan amount, I is that R divided by M, where R is the interest rate as a decimal and M is the number of compounding periods per year. And then this N, that exponent in that formula, there's a negative N on that parentheses. That's just the total number of compounding periods. Now, we can always use the TVM solver to calculate our payment, but this first example I'll show you we get the same answer either way. So it says you take out a 30-year mortgage for $195,000 at 6.75% interest to be paid off monthly. What is your mortgage payment? So we're trying to find the payment, or PMT, with the solver. And so N, well, it's 30 years and monthly payments, so 30 times 12, or 360. The interest rate is 6.75. So the present value, now this section we're dealing with loans and debt rather than investments. And so the present value in these sections will be like the loan amount if we're dealing with a loan. So the PV in this case would be 195,000. And this is traditionally why they make the PV negative, because that's your debt. So if you looked, like if somebody was giving you a credit score or something, whatever you owe on house or car, that counts as debt. So that would be negative. Payment is what we're trying to find. We'll hit a 0 there. We'll enter 0 there, and then later alpha solve. Future value, you don't want to owe anything at the end, so future value is 0, and there are 12 periods per year. And then we'll go back up and hit alpha enter at the payment. So 1264.77 if you round to the nearest cent. So that's your mortgage payment. And then I just wanted to show that if you use the formula, you get the same thing. And Math Excel, if you click on Help Me Solve This, might tell you to use formulas instead of the TVM solver. So I just want to show you that you would get the same thing. So there's your P, and then the I is the interest rate divided by the number of compounding periods per year. But you just have to change the rate to a decimal. So 0.0675 over 12 divided by, and then the denominator needs parentheses, 1 minus, and then parentheses again, 1 plus, and then there's that I again, 0.0675 over 12. And then that parentheses raised to the negative N, where N is the total number of compounding periods, or 360. So raised to the negative 360, close parentheses, enter. And notice you get the exact same thing, 1264.77. Okay, so this is what an amortization schedule will look like. And I think in Math Excel, it won't have this column for beginning balance, but a traditional amortization schedule will have your beginning balance for each period. Your payment will stay the same every time. And then the amount to interest will change as the loan progresses. More will go to interest at the beginning and then it'll gradually decrease so that by the end most of your payment goes to reducing principal. Okay, I think we do a partial amortization schedule the next page. Yeah, problem 8 from page 497. So it says James buys a house for $370,000. He puts $70,000 down and finances the rest at 6.3% interest, compounded monthly for 25 years. So part A just says find the monthly payment, and we're going to use the TVM solver to do that. So the total number of compounding periods, well, this was a 25-year mortgage, so 25 times 12. I was 6.3. PV, so that's the loan amount. So what would his loan amount be? Well, the house was $370,000, but he put down, he made a down payment of $70,000. So he doesn't have to take out the loan for the whole amount of the house. He only has to take it out for $300,000. Just make it negative. Payment, that's what we're trying to find. Future value is 0. We don't want to owe anything at the end, and the periods per year is 12. And so hit alpha solve there. So 1988.29. And that payment will stay the same every month. So that 1988.29, that always stays the same in the payment column. Okay, so for period 1, the beginning balance, so on your loan, you start out owing $300,000. And then you make this payment of $1988.29, but some of it goes to interest and some of it goes to principal. And so we will need to figure out how much of that goes to interest. Well, we can just use the simple interest formula, because if we're just doing one period at a time, the interest is not being compounded. So the I equals PRT, the principal is $300,000. The rate, we just have to do it as a decimal, so 0.063. And the time, well, T, remember, stands for the number of years. So for the first period, how many years is that if it's just one period? And remember, our payments are monthly. So then that is 1/12 of a year. So $1,575 of your first payment goes to paying off interest. And then the amount to principal, so that much goes to interest. So now we want to figure out how much goes to reducing the balance, or how much goes to principal. So it'd be the total payment minus the amount to interest. Oops. Yep. And I just hit that second negative key to get that answer. So the amount that goes to principal, that's what reduces our balance. So the remaining balance is the beginning balance minus the amount to principal. And I just hit that second negative key again. You can just type it in if you don't like using that. Okay, so now for the second period, so what would our beginning balance be for the second period? Yeah, it's what we ended the first period with, so that number just goes right here. And then we basically follow the same steps. The amount to interest, we just use this simple interest formula again. It's just that this now becomes our principal. And I can just hit times and it uses my last answer. The rate is still 0.063, and it's just 1 month, so still 1/12 of a year. And I'm going to round to the nearest cent. So 1572.83. And then to find out how much goes to principal, well, it's the total payment minus the amount to interest. And I typed it this time just so I would do only 2 decimal places. So notice that the amount to interest decreased slightly and the amount to principal increased slightly. So to get the remaining balance, it was the beginning balance of period 2, that $299,586.71, minus that. So that's how much we still owe at the end of the second month. And then the balance at the end of the second month becomes the balance at the beginning of the third month. And then we'll do the same thing to find the amount to interest. Multiply by the rate times 1/12 of a year. And round to the nearest cent. So 1570.65. So notice again, it's a little bit less than the previous periods. And then the amount to principal is the payment minus the amount to interest. And then the balance at the end of the third month is the balance at the beginning of the third month minus this amount to principal. Okay, so we've done part A. Part B says find the total amount that he pays for the house. And so we know his payments were $1988.29. So he made these payments, and then I just said how many times did he make this payment? Well, he made 25 times 12, which I believe is 300. I think I'll probably just do it on the calculator. Yeah. So he made 300 of those payments. So we're just going to do 300 times that payment amount. So he pays that $596, whatever I got. Now, what I did forget here is, and somebody points it out in a little bit, I forgot to add in the $70,000 that he put down. So he made these payments plus that one lump sum payment of $70,000. So find the total amount of interest he pays. Well, this was his loan amount, $300,000, and this is what he ended up paying on the loan. So you can just subtract those two. Whatever is the difference is the amount of interest he paid. So $296,487. So now I'm going back to add the $70,000 in. It won't change the amount of interest you pay. So, in fact, the total he paid for his house was $666,487. Okay, so part D says find the amount he still owes after 23 years. I write part B, but we're really doing part D. So 23 years, so to figure out how much he still owes, it would be his remaining balance at the end of this column. So if he's paid for 23 years, that means he has 2 years left, which means he has 24 payments left. So what we want to do is find the present value of that. And the reason we want to do that is because if he paid it off, his balance, if he paid it off that day, he wouldn't have to pay interest. So it's not just, you know, the payment times 24. We want to figure out really what's the principal left. I think I'm just explaining that probably here. Okay. So if we want to find the present value of that, then the number of periods is 24. We still have that interest rate. We're trying to find the PV. Now the payment, I just went and deleted everything after the place. And it changes the answer a tiny bit, but I think Math Excel will ask you to round to the nearest dollar, and it won't be off by more than $1 if you don't delete the stuff after the 9. Okay. So that means he still owes $44,724. And I think I put the cents as well. So if it said nearest dollar, then it would be $44,725. So that's his balance at the end of the 23rd year. And then part E says find the balance at the end of the 24th year. I changed them, but I didn't change them right. It should be D and E, not C and D. So at the end of the 24th year, then 12 payments are left, and we want to find that present value. So just the only thing we have to do is change the N from 24 to 12, and then just go down to PV and hit alpha solve. Okay, so 23,064.84. And then part F asks, how much interest do you pay in the 23rd year? And so what we'll do is figure out how much we decreased the principal by. So it went from 44,725 about to 23,065. So we reduce it by about 21,000, but we'll find that exactly. And then we'll find out how much we actually paid in that year. So we don't need the TVM solver. We're just going to use the regular. So first I'm figuring out how much I paid that year. Well, for 1 year there are 12 payments. So we paid $23,859.48. And then remember, we reduced our principal by a little over 21,000. Let's see exactly how much. Okay, so 21,660.14. So we paid that much, but we only reduced our principal by that much. So then to figure out how much of our payments went to interest, well, anything that didn't go to reducing principal went to interest. So we just need to subtract those two numbers. So about $2,200 went to interest during the 23rd year. I'm fixing to be the right letters. Okay, and then part G said do the amortization schedule, and we did that at the beginning actually. And I just said we really don't have time for equity, so we're going to skip that. Okay, so from page 494, So it says sometimes amortized loans stipulate a balloon payment at the end of the term. So it says, for instance, you might pay $200 at the end of each quarter for 3 years, and then you would maybe pay an additional $1,000 at the end of the third year. So your regular payments are $200, but at the end of the loan you pay an extra $1,000. That $1,000 is what they call the balloon payment. And so problem 12 deals with that. So it says a loan of $105,504.50 is to be amortized over a 5-year term. Oops, okay. So the one thing here, so notice it says there's a balloon payment. So when you're using the TVM solver to do problems with balloon payments, it says make the balloon payment the future value, and it should be a positive number. Okay, so it's being amortized over a 5-year term at 12% interest compounded monthly. So we know the periods per year is 12. And $10,000 balloon payment at the end. So we're supposed to calculate the monthly payment. So put a 0 there. That's where we'll hit alpha solve. And then our balloon payment goes in future value, and we make it positive. So put 10,000 there. And then the loan amount, that's our PV. So negative 105. Oh yeah, I put it in N. It should go in PV, and it should be negative. I don't know why I wrote it there. Okay, the interest rate was 12%, 5 years and monthly. So 5 times 12 or 60 for N. P per Y and C per Y are 12. So go back up to PMT and hit alpha enter. So 22, 24, 44. Okay. And then problem 16 says, in 1998, you purchased a house and took out a 25-year, $50,000 mortgage at 6% interest compounded monthly. In 2008, you sold the house for $150,000. How much money did you have left after you paid the bank the unpaid balance on the mortgage? So they're monthly, so we know P per Y and C per Y is 12. And then it was a 25-year term, so 25 with monthly payments, so 25 times 12. I erased that, but that's right. It should be 25 times 12. The reason I erased it was because it says in 2008 you sold the house, so that would mean 10 years later. So I put 10 times 12, but we can't do that part without figuring out how much our payment was, our mortgage payment was. So it says how much did you have left? Well, we have to know what our payments were before we figure out what our balance was. So we do actually have to use the whole 25 years. So first we're going to figure out what our mortgage payment was. So our N will be 25 times 12. The interest rate, they tell us, is 6%. The PV, so the loan amount was $50,000, so just make that negative. What we're solving for, so you can put a 0 there. We don't want to owe anything at the end. And so go back up to payment, alpha solve. So $322.15 is your payment. Okay, so now we want to figure out what did we owe when we sold, what did we still owe when we sold our house? So it says we stayed in the house. We bought it in 98, we sold it in 2008. So we stayed in the house for 10 years, which means we had 15 years left on the mortgage. And so if we had 15 years left, that means we had 15 times 12 payments left. So what we want to do is figure out the present value of those 15 times 12 payments. So I think that's 180. So N is 15 times 12. The interest rate is the same. PV, that's what we're trying to find. Payments, I think I delete everything after the cents place, but it won't really affect your answer if you just leave it. And then go back up to PV and hit alpha solve. So we still owed $38,175.91. So that's what we still owed on the house, but we sold it for $150,000. So how much money do we have left then? Or how do we figure that out? Well, we just do $150,000 minus what we owe. So almost $112,000 is what we profited. So $111,824.09. Okay, and then I think I just stop there.